So let's get started then. Hello everyone, I'm Gabriel. I'm with Gnosis AI. Today I'll be presenting a little bit of an overview about what we've been doing with Gnosis AI for the last roughly 2 years, 1 year and a half. Not sure if everyone is familiar with what Gnosis has been doing, but it's been around for roughly 10 years. They started with prediction markets. They launched a couple of infrastructure projects like CalSwap, most notably Safe, and now Circles, which I also touch upon this presentation. And yeah, let's get started then. Cool. Here a brief agenda. So I'll start with the trader agent, which is an agent operating on prediction markets, of course. The second topic will be the Safe Watch, which is an agent that is able to secure your transactions on Safe. The third thing is a kind of economic game around treasure hunting. And the fourth thing, if I have some time, is some bonus topics, which I prepared. Cool, so I don't think I need a very large introduction to prediction markets after a Clement presentation, but I'm not sure if everyone is familiar with polymarket or other prediction markets. So just a very brief, ultra short introduction. You start with an outcome or a question that you want to answer or have an estimate for. I can't use the laser, but so in this case, will any new airline suspend flights to 80 in this case? And you have two outcomes, so yes and no. Each outcome has a given probability of happening, right? So in this case, yes is roughly 57%, and no is 1 minus yes, so 43 roughly. And those probabilities are also the token prices. So if you are going to go to this market and place a bet on this, that means, let's say your view on this market is yes. Then you go ahead and buy this token, this outcome token yes, and this means that when this market resolves, and you hold yes tokens, each yes token entitles you to 1 unit of collateral after redeem if your bet was correct. And if your bet was wrong, you're entitled to nothing. So in this case, for example, the price was roughly 57%, so you can purchase each yes token at the price of 57 cents. And if your bet is correct and you redeem that for $1, you had a return of roughly 80% more or less, which is not bad. Yeah, so what I'm trying to say is there's a monetary incentive to update the price. So every time let's say you have a view on yes, and the market currently is pricing this at 57%. You go there and you purchase yes tokens, there's an AMM behind it, so the yes token will become more valuable, thus moving the odds towards yes. So it will be, the market has a larger odd of yes happening, and that's why you kind of move the market in the direction of the estimate that you are seeing, thus providing a profit potential to report the outcome in the correct direction, if that makes sense. Sure, and on the other side, it's also true. So there is a disincentive to misreport, simply because if you're betting in the wrong direction, your payout will be negative. So you're incentivized to provide valuable information to the market. Yeah, public odds then, as I said, act as a reliable information because parties are incentivized to report correctly. Cool. Yeah, and then quoting Vitalik here on this topic of info finance. So why are prediction markets interesting and useful? Of course, gambling is a big one, but prediction markets can also be used for info finance, where you start from a fact you want to know. So the question, will flights to 80 be suspended? And then you design a market to optimally elicit that information from market participants, which are incentivized to provide accurate information. Excellent. Cool, so coming back to our AI and trader agent. Our goal is get the highest possible accuracy on prediction market bets. So that means that for every bet we do, so every direction we pick, we get the proportion of those bets that were correct, and that's what we define as our accuracy. Let's imagine we have the highest possible accuracy. We have a Delphi Oracle, for example, which is 100% precise. What that would be the case, in that case we would have a Delphi-like behavior of future events. So we would be able to predict future events at 100% accuracy. Of course, very utopic, but that's what we are working towards, increasing our accuracy more and more. And as we have high accuracy, we can also leverage those trader agents to some other markets. For example, use prediction markets for decision making, and that's of course Futarchy, which I will touch upon in a few slides then. Yeah, diving a little bit deeper into the agent's actions, it is comprised of 4 big steps. So the first step is research. In that case, if the airline was going to suspend flights, then that might entail Google searches, Tavily searches. We also, of course, use different models for this search, Perplexity, among others, and different strategies. But in the end, what comes out is a research report. So it has previous flights, are there strikes happening, weather conditions, and so on and so forth. And with this research, we go to step number 2, which is a probability estimate. So with this probability estimate, we try to interpret that research and spit out a float value, which gives the estimate that this event will resolve into the outcome we're asking about. So in this case, it's the probability of yes, right? Because it's a simple binary market. Having this probability of yes and also a measure of confidence, we go to step number 3, which is the trade placement. So there, it's kind of a betting strategy, as we call it. So we then look at market odds. We compare with our probability of yes. We also compare our confidence, and we have some logic in place to determine, 1, which direction we are placing a bet on. Is it yes? Is it no? And also how big our trade should be. And that's where our confidence comes into play. Of course, if you are more confident about the prediction, we should bet more, and less confident, bet less. Finally, it comes to step number 4, payout redemption. That's simply collecting the payout if our bet was correct, or doing nothing if our bet was wrong. And here also a call out to the platforms we operate on, which are on the Gnosis chain, Presagio, which is the rebranding of Omen, and of course Seer, developed by the Claros team. Here's some results. By the way, all work is open source and transparent. I'm going to present a QR code afterwards with GitHub links, with the blog posts we are also publishing, and most importantly, the Doom dashboard to verify what we are doing. Here's the agent's betting accuracy on the y-axis versus time. You can see that in the last 30 days, the accuracy has been roughly 75% across all agents and across all categories, which is quite decent. And then here's the number of actions per day. So this includes both buy and sell, because the agent, the way we process it, the agent is triggered, so to say, every 2 hours. And then every 2 hours, it processes the markets and sorts and filters them by some conditions. And then it places a trade, either buy or sell, depending on the previous position. And for example, it's also interesting why the cells are there is because if the agent has placed a bet earlier and his view changed, or maybe this position grew too much, then there are also actions like take profit, for example, that the agent can take so that it incurs also a sell. So those kinds of actions are also part of the behavior of the agent. Cool. Now comes the Futarchy part. So it's basically governance decisions powered by prediction markets. Interesting quote here from Professor Hansen: vote on values but bet on beliefs. So doing a brief introduction again, as probably was presented before. Futarchy is useful when you're trying to make a decision and want to lever prediction markets for that. A simple example, should Ethereum implement the Pectra upgrade? So this is, you start with a question, and point number 2 is you want to optimize for a metric, for a given metric, which can be dangerous, but in this case, let's say there's a simple metric. You can have multiple, but this is a simple example. So the metric here is the ETH price. So you're trying to maximize the ETH price for this condition, for this decision, and with that you create 2 markets in parallel. So by this way you have 2 universes that you're also investigating. So universe number 1 on the top is you're trying to predict the price of ETH if the upgrade is implemented. So this is a scalar market which will convert to a given value if the upgrade is implemented. And conversely, on the bottom, there is a similar market to the price of ETH without upgrade. So you're trying to quantify the influence on the Ethereum price of the upgrade. So you wait for the markets to resolve, typically a few days, depending on the market. And you observe which market has the highest price, because that's what you're optimizing for. You want to maximize the price. In this case, the scenario on the top was the winner. So if the highest price is picked and implemented, that's the decision. So let's go forward with the upgrade. And the market on the bottom is just ignored. It's deemed invalid, and the money is returned to the users. Why that's useful as well is, okay, we made the decision, we implemented the Pectra upgrade. But let's assume in 1 year, but when this price is also observed, then there is a comparison being made between the Ethereum price and the price that the market resolved to. And people who placed a bet on the correct direction, which means that they predict the price well, they are incentivized, and if they predicted the price not very well, they also have a lower payout than they would have otherwise. So this is also to incentivize correct and good participation in broad terms. Cool. That was about Futarchy and the trader agent. Now comes the part about the safe watch and this agent that secures our safe. I assume I don't have to explain what safe is to you guys, but of course, after the Bybit hack, it became obvious that additional measures need to be implemented and need to be available. So we developed an agent, which we call the Safe Watch, which can act as a cosigner, and you can add this agent to your wallet, thus scanning your trades and also monitoring your trades, signing and rejecting the transactions in a continuous manner. The idea is it has different checks. It can scan for malicious addresses, blacklists, scammy addresses, scammy tokens, and so on. But the most interesting part is really the LLM analysis. So it acts as a kind of bank fraud detection. So I'm going to show some examples in a bit. But the idea is if it identifies some odd behavior when analyzing these kinds of data, like previous transactions, previous balances, which go entirely into the context, then it's able to reject said transactions. So it has some more context into whether this transaction is a fraud and should be rejected, or if it's okay and should be approved and executed. Yeah, this is the first example. So this is a non-malicious transaction. I just wanted to point out read out the LLM part. It just says that it's a swap of 250,000 euro for USDC, similar to previous swap. So it means I learned what you did earlier. So I know this is kind of thing that is allowed. It's part of your previous behavior. So I'll go. The LLM thinks it's okay and goes ahead and signs and executes it. Another example here, it's a malicious transaction. So this was flagged as potentially malicious because there is a large amount being transferred to a new recipient address that I have never seen before. So this means that the LLM is a little bit of suspicious because it's a new address, maybe a new token, a unusual amount. So in this case, it rejects the transaction and also sends a message to the user via the Safe APIs telling that, hey, I rejected that. Please do not go through with it. And this just illustrates this agent being a kind of bank fraud system, which learns from the previous transactions and tells you, kind of learns from your patterns, your behavior, and is also specific to you, to your needs, to your behavior, to your previous actions. Here's just an example depicting how it looks like if your transaction is rejected. You see here from the Safe UI that this transaction was, on-chain rejection there. One of them signed a rejection order, and then it cannot go through. Yeah, cool. How can I try it out? So everything is open source. So I'm going to present some links afterwards. Also important to notice is that the agent's permissions are limited. So the agent is not able to propose transaction or create a new transaction, but rather it can only sign. So either confirm and then execute that on chain. So we sponsor the gas fees on Gnosis chain because they're so low. And also the agent can reject the transactions if it's deemed malicious. Also interesting is that there are 3 ways to interact with the agent. First way is simply add the agent that we have running on our own premises as a signer to your safe. That's one possibility. Or you can also run the agent locally and then add this new agent to your safe if you prefer to try it out yourself. The second way is via API. So we also have some open API endpoints that anybody can test, and a web app which also people can test out. And it supports Ethereum mainnet and also Gnosis chain, as I mentioned. Cool. So this is the third use case. This is the economic game I mentioned earlier. It's called NFT Treasure Hunt. So most of you guys probably heard about the Freza agent and the Freza game. So there was this agent which got quite some attention in end of last year. And the idea of the Freza agent was it had access to a small bag of money in the beginning. And every time you try to send a message to the agent, you would pay some money. and the value or the cost of sending each message would increase over time. And why would people try to send messages to this agent? It was because the agent had this treasure which was increasing with value on time, so over time. So every time you sent a message to it, a portion of it would go to the treasure, so it had more and more money in the bank. And if you were able to crack Fraser and convince her to send you the money, you got the entire treasure to yourself. So it made sense to, it got quite some attention so that a lot of people tried it out. And some clever developer managed to crack Fraser. It used a very complicated prompt with, anyway, tons of tricks. And he was able to unlock roughly 50K from Fraser, basically, which was quite interesting from a security standpoint and how you code your agent. And we tried to do something similar, inspired by Fraser, but in our case, so we kept the treasure idea. So we have a bunch of X die in the treasure, and instead of having just one Fraser, we have 5 phrases, because to open the treasure, one needs 3 keys out of 5. So there are 5 sellers, each with 1 key. If one of the buyer gets 3 keys, it can open the treasure, thus having some monetary reward. But it's actually tricky, because one of the agents, so seller with 3, for example, it was coded in a way that it's a trickster, actually. So we coded it in a way that, hey, try to trick everyone to send so that they send you a lot of X die or a lot of ETH or whatever, but do not send the key under any circumstances. So it's a trickster, a fake seller. Whereas the other sellers were coded like, try to get as much X die, which is the gas token on Gnosis chain, as possible, and then send them the keys. So they are real sellers, although there is one that is a trickster. And the buyers were given also an initial amount of X die, and their objective is to open the treasure and have a monetary incentive. And we let this game play for a while and had some interesting conclusions. And yeah, this is how the game looks like. It's a simple web app. You can see the agents here on the left-hand side. We played that during DAppCon, during the Gnosis conference some weeks ago, and it was quite interesting to see the agents playing around with each other, because they can also send messages between each other, mediated by the chain. And within those messages, they then try to, okay, I can offer you this amount of money in exchange for the key. They can negotiate and they can enter an agreement, thus exchanging keys, which are NFTs as well. So what we were trying to learn from this experiment was mostly 3 things. So can agents learn? That's the first question. And what we observed is, yes, they can learn, because we also implemented a way for the agents to reflect. So there is a round, they play, they try to get the keys, somebody wins and open the treasure. Then we also reflect that with the past activities. So we tell the agent, this is what you did in the previous round, this is what other players did in the previous round. Learn and reflect what worked, what didn't work. And we observed, for example, that an agent had interacted previously with the trickster that would never transfer the key, and saw that it didn't work. And then the next rounds, this agent did not interact with the trickster, or interacted less often. So that was interesting. The second part was, if the second question we asked ourselves, can agents cooperate, form alliances? And we didn't observe that. It was mostly a one against all. The interesting part was mostly a role change. So if you remember here, there were 5 sellers. One of the sellers decided actually to accumulate other keys, which kind of went rogue. That was not expected, but definitely interesting. But alliances, so more agents trying to, let's cooperate to get a key, and then we open the treasure and split the rewards. We haven't seen that, but would be curious to see maybe more agents, or you guys also playing the game and finding out some other behaviors. And the third thing, which I find the most interesting, is can agents start a tiny economical system? So can one agent, for example, act as a market maker and work on both sides? So he both buys keys and sells keys and tries to arbitrage or make some money on the spread there, or even borrow some money to purchase key, which is similar to the second point here. And that would also be quite interesting, because that allows kind of a economical playground using the agents. But that's also still in the idea phase, but would be nice to observe those behaviors as well. Cool. I have some bonus topics now that I would like to present. Not sure. Do I have time now? Awesome. So cool, I went fast, so that's the reward. So the first point is identity for AI agents powered by circles that I would like to briefly touch upon. And the second point is how to improve our agents' predictions, which is the trader agent, the first point that I was talking about. So getting started with circles then. Yeah, I don't want to explain too much about circles. We have a booth outside. Also, Martin Koppelman did a presentation about this with much more detail. So just briefly touching upon circles and what it's about is a experiment with a new form of money. So we think that this kind of, so circles is a more fair economical system where issuance is decentralized and not just the power, not just possible or centralized by a few central banks or institutions. Rather, in circles, anybody can mint their own circles and at a fixed rate. So this gives power to everyone, basically. Yeah. 3 basic rules. Circles issuance is fixed at 1 circles per hour, unconditionally. Everybody can mint their own circles at this rate. Then the second point is the 7% demurrage per year. So you can see it as in the beginning, the supply, since you have very little circles, your supply is low, you just mint, so your supply is just going up. As this increases, demurrage becomes relevant, so this kind of plateaus here at roughly 100,000 circles. And as you either stop using the platform or you die, or your balance just goes down because demurrage just applies and you're not minting anymore. So it's kind of a plateau and then it goes down. Yeah, please refer to the documentation for more details here. And also the third point, which is the most interesting also in my opinion, is this selective trust system. So what that means is that if I trust Alice, for example, inside circles, that means that I accept Alice's tokens as if they were my own, so at a ratio of 1 to 1. And this trust system is what gives Sybil resistance to the network. So that means that if I don't trust another party, then I'm not prepared to accept his circles. So if somebody else just has 10 bots here and I see activity on chain or activity on the circles network of those bots just transferring their circles back to this person, I can identify this person as not being compliant with the rules of the network. So I don't trust her, I don't trust this person, and nobody should trust this person. So it's kind of a social Sybil, soft Sybil resistance. Yeah. Yeah, and just concluding the idea for circles, there are 3 main entities in circles. Of course, humans, which are able to mint circles and trust other participants as well. Then there are the groups, which are kind of facilitators in this entire circles ecosystem. So they allow for easier exchanges of money. There's not the need to have a direct person-to-person connection in order for the trade to occur through what we call the pathfinder. But you can also have trust between groups, which facilitate this kind of transfer there. And they represent just aggregations of humans. So there's a group for FCC, there's a group for Paris, for Berlin, and so on and so forth. And the third entity type is called organization, which is the relevant part for this talk here. And an organization can be the ice cream parlor, can be a supermarket, or can also be an AI agent. And the idea for an organization is it needs to provide services for the network. And also important, an organization cannot mint circles. This is reserved for humans. Organizations are only are just nodes in the network that provide services in exchange for circles or for money or something like that. They cannot mint. In this case, they provide services, of course, forecasting services, because that's what our trader agents are already doing. And we leverage the circles web of trust as a reputation system. So in this case, if you can see on the image on the top left, the Delphi agent, again, is offering forecasting services, and Alice trusts Delphi in order for it to provide the forecasting results that she's after. So if she's satisfied with those forecasts, then she can trust the agent, and other people can also look at that and say, okay, if Alice trusts the agent, then I also convinced that the agent provides some relevant services. Let me trust it as well, and that gives a kind of reputation score, or review score for the agent, similar to the Uber review scores and some other applications as well, but supported by the circles network with lots of users and incentives for trusting untrusting people. And yeah, to summarize, trust level acts as a proxy for the agent's performance. Thank you. And yeah, my final topic here is ideas that we have or how we are planning to improve upon the agent's prediction accuracy. Yeah, here's some thoughts. Again, this is the same chart as I presented earlier of the accuracy over time for all the agents. I would argue that the accuracy is pretty decent, so we're doing a good job there, but we also observe as we manually inspect the predictions that the agent is overconfident. So for some of the predictions that he's making, he's claiming that his confidence on that prediction is very, very high. However, it should not be high for many reasons that we also can demonstrate, which is simply it's not possible to predict with that confidence because we know we manually inspect the events and so on. And we're trying to solve that. We're trying to make the agent have a better understanding of how confident it should be about the prediction. And the two approaches we're using for basically getting this prediction or this estimate of the agent are either asking the LLM directly for a prediction plus confidence, so you get two floats. That's the easiest approach. Or you also take the log props as a measure of confidence. So that means the log props are just what the LLM also outputs as a next token, because we're asking it for if you believe that this outcome will resolve to yes, output y, the character, or output n as also the character. So getting the log props there just is a measure of how confident the LLM is in the prediction it just made. And we use that as confidence for the further trading activities. A much more interesting approach would be to call the LLM for and ask it for a measure of the distribution, of a measure of the confidence that it has in the prediction itself. So let's say we asked the LLM, we are trying to predict the Tesla price at date X, and we asked it for the 5% and 95% probability distribution, and just those two levels, we're able to fit a parametric distribution using those two values. For example, a beta distribution. And in this case, we take the mode of this distribution that we just fitted, and then we use that as our estimate, for example. And why this is a lot nicer than the previous two approaches is because you have a concrete measurement of your confidence. So you're able to say, given the distribution that I fitted my data with, now I can tell okay, this is the deviation, or this is sigma. I can take any kind of measure from this distribution. And also, I can update this as this is now my prior. If I do similar predictions, I can also update this distribution with the additional resolutions that I had, thus updating my confidence interval. Yeah, that's what I had just to tell today. Thank you so much for your attention. Happy to take any questions.
Yeah, question here.
So one of the most efficient prediction markets and most mature ones are sports outcome prediction markets. And now we have like fully on-chain sportsbooks such as overtime.io and stuff like that. So is it possible for your AI to eventually also become like an automated trader on those type of platforms, or is that like a gray area?
Good question. So this accuracy that I reported here, this is across all kinds of markets. Sports. We also place bets on sports markets, politics, crypto, any kind of market, and this is across all of those markets, and most importantly, across all kind of how far away they are from the resolution time. So it's very different to try to make a prediction 1 minute before resolution than to, I don't know, 15 days before the game, for example, where some player might be injured, for example. That, of course, affects the prediction. So unfortunately, I don't have an answer for you on how effective that could be and what is the performance for those specific predictions. But I guess, not really I guess, but the procedure is the same, right? So the 4 steps of research and doing the estimate and betting on those markets is definitely the same. It's just a matter of how good your data is and how predictable the event is then. Yeah.
Just a quick one. The Tesla chart inspired me to ask this. So is it possible then for this AI agent to actually become a market maker, because it can accurately kind of price distribution curve and stuff like that? So instead of like a trading agent, it could become like a order book market maker of prediction markets, right?
if it can become a market maker because I'm predicting the price. Is that the reason?
Yeah, because it kind of predicts the confidence of the price of Tesla, for example, in 1 month, and based on the curve, it can actually fill the order book based on that curve, for example, on Polymarket.
I'm not sure a market maker is the best behavior for the bot, for the agent in this case. I mean, in this case, as we are predicting the Tesla stock, for example, we have a price or we have a distribution and the most likely price. So the way that we would act in this case is simply to place a bet in the direction we're viewing that. So and that's the estimate. But of course, having this kind of prediction, then you can go on both markets and have profit from the spread for sure. But that's not really the goal of the agent of what we are trying to do. Does that answer your question?
Yeah, thanks.
Yeah, I was just curious about the return from like the chart. Yeah, just if you could speak to that.
This one?
Yeah, but I'm curious about the return. I mean, this is the accuracy, so I'm curious about return. Because, I mean,
Yeah.
you could... yeah, go ahead.
That's the chart I didn't include. It's on the Dune dashboard. But so the return is not bad. Let's put it like this. I don't have the number in my head, but it's definitely it's positive. We don't return the APY overall. It's just the last 30 or 60 days. So you can check it out. So I don't want to provide false data. However, what is not in there is the inference costs that we incur using OpenAI, which are very not very high, but it's, I mean, for every prediction we do have inference costs, which are not taken into consideration for Dune. But having said that, we're not optimizing for those costs as well. You can say run local models. You can say batch markets together. You can use cheaper models for some markets, more expensive models for other markets. So there are some tricks, but please check out the Dune dashboard. Yeah, thank you.
Any questions?
So you say the agents were often overconfident. Did you try just simply calibrating them? Like if you can put a chart of if the agent predict 40% and on average when they predict 40% it's only 20%. So in this case you can just calibrate them as long as it's a bias. Like bias are very easy to correct. Did you try that?
Not yet. We are still doing one of the easier approaches of just asking for accuracy for the prediction, for the estimate, and then the confidence. And we're just implementing this new, let's say, predict distributions. And then you're right. We do have the data for the calibration because we check on our estimate that we do versus the market resolution, and you observe there's already a bias. So we expect to calibrate that by the data as well. Yeah.
No question? Okay, thank you.